Okay, here we are with experiment 20. I'm on the second page of experiment 20. Let's see, the first page looks like this. Okay, so I'm going to walk you through some of these problems. The main thing, these problems are conversion factor problems in disguise. So let's look at number one. How many mils of a 22.5% volume per volume ethanol solution would you need to measure out in order to have 12.5 mils of ethanol? And the molar mass is provided, 46.07 grams per mole. All right, so with these problems, first thing you need to do is determine, are they asking you a concentration or are they asking you for a conversion? And this is a conversion. They didn't ask explicitly whether it's mass per mass or molarity, that type of thing. So if it's a conversion problem, what you want to do is circle your starting quantity, and this is your conversion factor. And I'm going to be a little bit pickier about how you write out your conversion factors. This is 22.5% volume per volume. So you really need to say 22.5 milliliters of ethanol, and I'm abbreviating ethanol ETOH, over 100 milliliters of solution. Okay, so now what we're going to do is carry out this conversion. So we're going to put 12.5 milliliters, and they're asking for ethanol, over 1. So one of the biggest challenges students face is instead of putting the starting quantity over 1, they will start with their conversion factor. And that is going to lead to a lot of craziness with units. So just be on the lookout for this. Okay, so now with our conversion factor, not only do we need to get milliliters to cancel out, but we need to get milliliters of ethanol. So we're going to put 22.5 milliliters of ethanol over 100 milliliters of solution. And our milliliters of ethanol cancel out. Use our calculator. So 12.5 divided by 22.5 times 100, and we'll end up with 55.6 milliliters of solution. Now, for sig figs, you have to take into consideration both your starting quantity, so that's 3 sig figs, and your conversion factor, that's 3 sig figs. So that is how you would work that type of problem. Next one that I'm going to work is number 2 with you. How many grams of sodium hydroxide are in a 225 milliliter sample of a 2.5 molar solution of sodium hydroxide? A molar mass is given. Oh, and by the way, molar mass is provided whether or not you need it or not. So you really need to know what you're doing, or else you might start with your molar mass and think, I need it. Usually the only time you need molar mass is when you have molarity, often used with M. So this question, we're asked to find grams of sodium hydroxide. We're given milliliters. So our starting quantity is milliliters. We're trying to get to grams. Milliliters to liters, liters to moles, moles to grams. So this conversion factor here is 2.5 moles over 1 liter. This conversion factor here, this is hard to see, is 40 grams over 1 mole. And this is just your ladder conversion factor. So our starting quantity, I'm going to circle again here. So this is a conversion problem as well. It's not asking for concentration. And this is our conversion factor. So we're going to start with 225 milliliters. over 1. And then we're going to say 1,000 milliliters, 1 liter, and then 2.5 moles over 1 liter, and then 40 grams over 1 mole. So milliliters, milliliters, liters, liters, moles, moles. So 225 divided by 1,000 times 2.5 times 40. So 22.5 grams. We're going to base our sig figs off a starting quantity. So that's 4 sig figs. And then also our conversion concentration, which is 2 sig figs. So our answer cannot have more than 2 sig figs. So that's how we get 23 grams. Okay, so far we have worked 2 conversion problems. We did use the molar mass on the second one, and notice that that's because we had molarity. Remember, molarity is not a percent concentration, it's just out of 1. I'm going to show you on the next page, so this is page 152. Let's work number 8 together. Okay, a mixture of salt and water is 28.0 grams and 60 grams of water. What is the mass percent salt? So you are asked for a concentration. This is a concentration calculation. Okay. So remember that mass percent is equal to grams of solute over grams of solution. So we have the grams of solute, 28.0 grams salt. And then we have the solvent. Remember that solution is not solvent. Solution is equal to solute plus solvent. So in that case, it would be 28.0 grams plus 60.0 grams. You get 88.0 grams of solution. And then you multiply that all times 100. So you end up 28 divided by 88 times 100. So I end up with 31.8. I'm going to use 3 sig figs. And the units on this, there are no units because our grams cancel out, but you can put percent since it is a percent concentration. So this problem was a little different. You're not looking for a starting quantity and a conversion factor. You're looking for the grams of solute, the grams of solution, and sometimes you may have to add them together. Okay, so the rest of the problems on page 151 and 152 are some sort of conversion or concentration calculation. So be careful with these. I highly recommend circling the starting quantity and then writing out your conversion factors in this format. It's going to take you a long time to figure this out. Remember, the molar mass is not always needed. Now I'm going to flip back to page 149, and with this, you're given a lot of data, and it's kind of several different problems in one. One part of it is you need to identify different grams of solute, grams of solution. Then it's a concentration problem where you're asked to calculate mass percent, mass volume percent, and finally you're asked to calculate the molarity. So it looks really intimidating. All the information is here. You just have to stay cool and not panic, which is sometimes easier said than done. So, okay, you read this, blah, 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 blah. I just want to get done with this, right? Okay, so the mass of the NaCl solution. What you're looking for is to find the beaker in solution, so that's 54.129. So that includes the beaker, so we just need to subtract out the beaker. So this one we're going to take 54.129 grams minus 42.889 grams. Remember your rules for sig figs was subtraction. It's after the decimal. So we have 3 after the decimal in both of these. We should have 3 after the decimal in our answer. So our answer that we get is 11.24, but I need to put a 0 after that. So the solution is 11.240 grams. Mass of the dry NaCl, we're going to subtract this from this, so 44.079 grams minus 42.889 grams. So 1.190, add that 0 again. So we have a lot of the key information to calculate these next things. So we have grams of solute, grams of solution, so we can very easily calculate the mass percent. When I say easily, I'm not trying to be condescending, but it's there. It definitely gets easier the more you work these problems. So NaCl solution times 100. Pay attention to sig figs. You have 4 sig figs here, 5 sig figs here. So 4, 5. Our answer can't have more than 4 sig figs, so we get 10.59%. All right, mass volume, grams of NaCl over milliliters of solution. So we know 1.190. We'll use that again. The milliliters are right here, so it's back in a question. So 10.00 times 100. So we get 11.9. We have 4 sig figs here, 4 sig figs here. Our answer must have 4 sig figs. Okay, so we calculated the mass percent, we've calculated the mass volume percent. Now we are setting up to calculate molarity. Remember that molarity is moles over liters, and it's not times 100. So what they're walking us through is calculating the moles, calculating the liters, and then eventually dividing it out. So we're going to take the dry NaCl mass, which is 1.190 grams, convert that to moles. Remember, you can do that with your molar mass. And don't put grams/moles on the bottom. Remember, you can divide by the reciprocal. When you divide by a fraction, it's the same as multiplying by the reciprocal. That's what we have here. Our grams cancel out, and we'll have our answer in moles. And so we end up with 0.2036 moles, 4 sig figs. Volume of the solution in liters. We have the volume of the solution in milliliters. So in order to convert it to liters, I'm going to move this 3 to the left. So 1, 2, 3. That puts my decimal here. So I have 0.01. Now be careful with your sig figs on this. These zeros are all significant. So that's 3 after the 1. So there. Okay. So now I have these two quantities. I'm just going to plug these in to calculate the molarity. So 0.2036 divided by 0.01000, and we get I made a mistake. And you're probably noticing this. I forgot to put a 0 right here. So just be careful. I forgot to put the 0 here, and it's easy to do with these types of problems. So just double check your answers, and it's nice that I made it so I can show you that even experts make mistakes. Man, I've done this problem like probably 150 to 200 times over the years, but so little details are easy to miss sometimes. So just make sure you're entering your calculator stuff twice and paying attention to those numbers. Okay, here's the correct answer, 2.036. And now you can write moles / liters if you'd like, or you can write capital M, that's the abbreviation for molarity. So I know this is a lot of work. Remember that on our upcoming Unit 5 exam, we're going to have a lot of these problems mixed together. On page 150, we have great practice. It's a very similar setup to page 149, so go ahead and work that and look at the rest of these problems. So if you have any questions, please send me an email. You're always welcome to take a picture of your work, and if it's not going well, or maybe you forgot a 0 like I did, we can figure it out. But thanks for watching, and I hope you have a great day.